Hi everyone, it's Coach Red here, and today I'm going to be talking about solving polynomial equations. I'm actually going to be looking at solving polynomial equations that are non-quadratic, right? Meaning the highest exponent is not 2. And we're going to do these by factoring right now, okay? Because we haven't learned other techniques yet. So we can factor polynomial equations. But it's really important to look at what they're asking you to find, because they could be asking you to find the complex solutions, which means the real and or imaginary solutions. And sometimes they might just ask you for the real solutions. The real solutions are the ones that are going to have x-intercepts. That's where an x-intercept is going to lie. Remember, imaginary solutions, the graph won't cross the x-axis because we can't plot the imaginary solutions on a standard xy coordinate plane. So really thinking deeply about the difference between real solutions and complex solutions is going to be important, okay? I specified here, I said find the real and or imaginary solutions to each polynomial. Okay, so if I'm looking at this first polynomial, it's a degree 5. But remember, before we even begin to factor, it has to be in standard form. So I'm going to have to rewrite this. Okay, and so from there, I'm going to look for a GCF, and I see that I have a GCF of 2x. I could divide out the 2 if I wanted to because it is an equation, so I could also do that. That's going to give me x to the 4th minus 7x squared plus 12. Okay, so I'm going to factor some more. It's quadratic form, so I'm going to have x squared minus 4 and x squared minus 3. Equals 0. Now I could keep factoring those, which is the way I'm going to do it, or I could have set each of these factors equal to 0 and solve. I'm going to go one more step on this because I'd like you to see something interesting. So I can see that I have dots right here, x squared minus 4, x plus 2, x minus 2. And actually we could consider x squared minus 3, we could consider it dots because it could be factored into x squared minus root 3 and x squared plus root 3. But we don't normally think about that. We only typically think of dots when the number is a perfect square. But remember, root 3 times root 3 will give me 3, so it works with non-perfect squares as well. All right, so if I set each factor equal to 0, I'm going to get x equals 0, x equals negative 2, x equals 2, x equals root 3, and x equals negative root 3. Okay, so you can see I have 1, 2, 3, 4, 5 answers, all of which are real. These are just irrational roots, but they still can exist on the coordinate grid, so on the x-axis, whereas imaginary, I didn't get any. Okay, all right, now let's look at this next one. I can see it's in quadratic form, so I need to get it set equal to 0. And I'm going to solve by factoring. I'm going to do this one slightly different. So that's going to give me x squared minus 4 and x squared plus 1. Okay, so I can clearly see that I have dots here. That's going to be x plus 2, x minus 2. Now this one, I'm going to set that factor equal to 0 because I'd like you to see what happens. It looks like dots, but dots is difference of 2 squares. This is the sum. The sum of 2 squares will always end up giving us an imaginary solution. So if I solve for x here, I get that. I take the square root of both sides, and we recognize that that's going to give me plus or minus I. And these, if I set them equal to 0, are going to give me x equals 2, x equals negative 2. So I know that this graph has 2 real solutions and 2 imaginary solutions. And that means that the graph is only going to touch the x-axis twice. Now, if I kind of put this back together with what we've learned about end behavior of a graph, I know that my graph is pointing up because it's a even degree positive leading coefficient. I know I've got 2 x-intercepts, and then I could find what's happening in between all of those if I wanted to plot some points, okay? Okay, so that's it. It's a quick and easy way to solve polynomial equations by factoring to find all of the complex solutions, meaning both the real and imaginary solutions. Look out for that when you're asked to solve, okay? Have a great day.